Welcome to the Edge of Reason, where mathematics collapses and the universe reveals its most terrifying secrets. Today, we're tackling a rule you learned in grade school: never divide by zero. But this isn't just a classroom exercise. This simple prohibition is the key to understanding one of the most mysterious and destructive objects in the cosmos, the black hole. So, why is dividing by zero the ultimate mathematical sign? And what does it have to do with the crushing, infinite density at the heart of a black hole? Let's start with the basics. What is division? At its simplest, it's about sharing. If you have 10 cookies and 5 friends, you can divide the cookies among them. Each friend gets 2. 10 divided by 5 is 2. Mathematically, division is the inverse of multiplication. The equation 10/5 equals 2 is true because to 5/10, this relationship is the bedrock of arithmetic. It's clean, it's logical, and it always works. Until it doesn't. Now, let's break the rule. Let's try to divide by 0. What is 10 divided by 0? Let's call the answer x. So, 10 as 0 equals x. If we follow the inverse rule of multiplication, this means that x multiplied by 0 must equal 10, but we all know that any number multiplied by 0 is 0, not 10. There is no number in the entire universe that you can multiply by 0 to get 10. The equation is a lie. It's a contradiction. It breaks the fundamental laws of mathematics. This is why your calculator flashes an error. It's not that it's not powerful enough to compute the answer. It's that there is no answer. The question itself is meaningless. Some of you might be thinking, but what about infinity? As you divide a number by progressively smaller and smaller values, 0.1, 0.01, 0.0001, the result gets larger and larger, shooting off towards infinity. So, isn't the answer to 10 divided by 0 just infinity? It's a clever idea, but it doesn't work. Infinity is not a number, it's a concept. It represents a process of endless growth. You can't just plug it into an equation like a regular number. It doesn't follow the rules. For instance, what is infinity minus infinity? Or infinity divided by infinity? The math breaks down into a mess of undefined forms. So, we've established that in the clean, orderly world of mathematics, dividing by 0 is forbidden. It's a dead end. But the universe isn't always clean and orderly. In the cosmos, this mathematical impossibility takes on a terrifying physical form. Enter the black hole. A black hole is an object of such immense mass and gravity that nothing, not even light, can escape its grasp. They are formed from the collapsed remnants of giant stars. At the very center of a black hole lies a point that physicists call a singularity. And it's here that our division by 0 problem comes roaring back to life. According to Einstein's theory of general relativity, a singularity is a point of 0 volume and infinite density. Think about that, an entire star, or even millions of stars, crushed into a space smaller than an atom. A point with no size, but with nearly infinite mass. The equations that describe the physics of a black hole literally have a division by 0 in them. The radius of the point is 0. When you try to calculate the density mass divided by volume, you are dividing by 0. Just as in our simple math problem, the laws of physics as we know them break down at a singularity. Space-time becomes infinitely curved. Cause and effect cease to have meaning. The equations that have so beautifully described the universe, from the orbit of planets to the bending of light, simply stop working. They return an error message, just like your calculator. This division by 0 at the heart of a black hole is one of the biggest unsolved mysteries in all of physics. It tells us that our current understanding of the universe is incomplete. General relativity, our theory of gravity and the very large, is incredibly successful. But it can't handle the infinite density of a singularity. On the other hand, we have quantum mechanics, our theory of the very small, which governs the world of atoms and particles. It also works perfectly in its own domain. The problem is, these two great theories of physics don't play well together. And a singularity is where they collide head-on. It is both incredibly massive, the domain of relativity, and incredibly small, the domain of quantum mechanics. Physicists believe that to truly understand what happens at the center of a black hole, we need a new theory. A theory of quantum gravity that can unite relativity and quantum mechanics and describe what happens when immense mass is squeezed into a quantum-sized space. This new theory would, hopefully, get rid of the division by zero. It would smooth out the singularity, revealing that the density isn't truly infinite after all, but just really, really, really big. So, the next time you see that error message on your calculator, remember what it really means. It's not just a glitch. It's a window into the limits of logic and a signpost pointing to the deepest mysteries of our universe. From a simple forbiddance calculation comes the mind-bending reality of black holes, where the laws of nature are torn apart. The rule is simple: never divide by zero, because when you do, the universe as we know it ends.